Minglava. So far, we have learned how to import the data and you did the data cleaning, right? And today we are going to learn the next important step of the data science project, which is exploratory data analysis. In short, we usually call it as a EDA. What is EDA? It is an initial investigation of the data to describe the main characteristic of the whole data set, right? Or it could be an individual variable you have there in the data set, or understanding the relationship between variables. This is a very important activities in your data science project cycle, right? Because depending on EDA, you will be able to answer how does your data impact the final goal, right? In the business context, what will be the additional value that you can provide from the data? For you to do so, you need to understand your data. To understand your data, you need to start asking questions yourself. What was your initial goal of doing this project, right? What were the views of the stakeholders in your problem defining stage, right? You need to brainstorm, okay? And what kind of information I want to extract from this data set. Let's start with understanding the data, okay? To understand the data, what we need to do is we need to first look at the data set, all right? And to understand what are the variables provided, how many records do we have, what are the data types, are they all numerical or categorical values, what is the semantic context for each variable, and what do we expect from these variables, how do these variables relate to our final goal, right? We have cover a number of Python functions which can give you the basic understanding of the dataset. For instance, the f.shape give you the information about the number of records you have and number of variables in your dataset. From this, you can see whether the number of records is sufficient for you to represent the population. The variables that you have collected so far, is it sufficient to answer your question? df.golang give you the name of the variables or columns. From this, you have to understand semantic context of each variable. For instance, in our dataset, when we look donor dataset, what do we mean by income? What do we mean by acquisition investment? These are the information we need to understand. All right. And next, df.dtypes give you a handy tool to check the types of the variable. They are numerical, they are categorical, or are they date and time format? Right. Likewise, df.head or df.tail give you a way to quickly access the small set of data. This is very useful, especially when you have a very large data set. Right? Okay. Next, we also can use the df.info to summarize your data set. All right. So if you call df.info, it will give you the number of rows, number of columns, which are variables, and what are the column names, and what are the data type in one line. All right. So in our donor data set, we can see that there are 932 entries and 932 records with 10 columns. It is also give you the data type for each column, each variable. All right. Okay, now let's think about our objective. Our objective of this project was to determine which investment program give us the highest return on investment. So now when we look at this data variables that we have, we don't have the return on investment. So next, we need to calculate the return on investment. All right. So return on investment, we know the formula. We can minus the total investment from the income and divide by total investment. All right. So this is a formula we have already do it. So in Python, it's very easy to create a new column. Okay. We have to create a new column by manipulating on the existing column. So if you remember, we have the column called income, and we also have the column for do investment, acquisition investment and retention investment. All right. And then you have to divide by total investment. Here, please pay attention. All right. We need to bracket here. Otherwise, this will be the wrong. Okay. Total investment, acquisition investment, and retention investment. When you need to sum it out in the bracket first, then minus it. Right. So please take note the mistake here. Okay. So here we can create a new column called return of investment. All right. Okay, now we have a data set with the column that we want. Now let's look at the individual variable. All right. So for each individual variable, we want to compute the statistical values for each column or each variable. All right. So just now we talked about the summarization of data using the DF info. Likewise, df.describe give you a way to describe the basic statistical features of each variable. Let's see what we can do. This is a result obtained by df.describe. You can see that df.describe calculate the statistical values for each numerical column. In our data set, there are 5 numerical values, which are year, the income, investment during the acquisition, investment for retention, and a new column that we have calculated, return on investment. All right. So for each individual variables, the df.describe calculates for you statistical values such as average, standard deviation, minimum, maximum values. Not only that, it also gives you the first quantile, then third quantile, or also the median value. All right, so 25%, 50%, 75%. From this df.describe, we can see that the distribution of the data. Okay, so if you look at the count, we see that all the columns have 931 records. And over these years, all right, the minimum year was 2012, maximum year is 2020. So from this, we can see that the year that the data has been collected is for 8 years, 2012 to 2020. During these years, the average income was 110, 1.1 million. No. All right. It's 1, 2, 3, 4, 5, 6. Yeah. So it is about 1 million. All right. And for the investment that we have spent is about 41,000, but retention investment was only 7,000 on average. And we have the return on investment of 9102. Right? So this is what we have to understand from the df.describe. We have to interpret what we see from the statistical values. Right? So if you notice that df.describe calculate only for the numerical value. It doesn't calculate for categorical values. It makes sense, right? Of course, we can use the keyword. We can provide a parameter to include all the categorical and numerical values. Right? Okay, but it makes more sense to use the df.describe for numerical values. So what we can do with the categorical values? Of course, we can look at each categorical values using the value counts. All right. So if you use a value counts for each categorical column, it gives you the summarization. For example, summarization, right? For example, here I'm looking at the investment program. Okay. For the investment program, we can see that there are 5 unique investment programs that we have run. And there are 386 records for online donor acquisition, 203 for ISFR face-to-face agency, and so on. All right. So we can also see here that we have a very small number of acquisition mail in the data set that we have collected. So it could be possible that we don't have a lot of progress and other acquisition mail, or this data set didn't include. All right. So this shows the imbalanced data. So by just checking on the value counts, you can see that for each variable, whether the data is balanced or not, right? Okay. We can also use the value counts and set the parameter normalized to be true to compute the percentage. All right. So if you use the normalized to be true, we can see that the values are given in one decimals. All right. So here we can see that 41% of the program we have from 2012 to 2020 are online donor acquisitions. 25% is face-to-face through the agency, right? So this is how we can calculate the basic descriptive statistical values for both categorical and numerical values, right? Next, we are going to study more on the grouping of data, right? How does these variables correlate each other? So remember to subscribe my channel. Thank you very much. See you all in the next video.